Alright guys, this will be the first video of two parts for the section 12.1 notes. It is basically an introduction to sequences and summations of those sequences. And the first thing that we do, we're going to jump right in and define what a sequence is, very mathematical definition. A sequence is a function f whose domain is the natural numbers. Those are the counting numbers, 1, 2, 3, starting with 1, going in positive integers. That's what a natural number is. The terms of the sequence are the outputs of f of 1, f of 2, f of 3, all the way to f of n. That would be the nth term, maybe one we don't know. Okay, so really these f of 1, f of 2, f of 3, f of n represent terms of the sequence. Okay, just like a sequence that you guys used to mess around with back in the day where a teacher gave you a sequence and said find the next two terms. Okay. Normally, when we're thinking of sequences, we use the letter A to denote a sequence, but as you'll see in some of our examples, they can really be denoted by any variable in terms of naming a sequence, just like we can use any variable when naming a function. We've had function f, function g, function h. It just basically determines what function we're talking about. But traditionally, the sequence is written as such. And we use subscripts, so that's a sub 1, a sub 2, a sub 3, a sub n minus 1. We'll talk about what those mean. When we say a sub 1, this means, and this is what we say, that's the first term of the sequence. Okay? This would then be the second term. This would be the third term. And this, a sub n, is really the sequence itself, or the definition, or what we say the nth term. And we'll talk about this a sub n minus 1 once we get a little bit later in the notes. Okay, but just basically a definition of what a sequence is, some terminology of what you're going to see as we go through these notes. So the first example, find the first three terms and the 100th term of the sequence defined by each of the following formulas. So what we have here, each one of these four sequences is defined by what we call an explicit formula. Okay, where the sequence is written in terms of n. Okay, so the nth term is written in terms of n. And very simply, if again we're thinking back up here where we're thinking about functions and seeing that we have an n here where the subscript is and an n here, well, if we're thinking, well, I want to find the first term of the sequence, well, the first term is a sub 1, and if we're going to put in a 1 in place of this n, if we're thinking like a function, we would put a 1 in place of that n, 2 minus 1. The first term of the sequence is 1. The second term, not a sub 2, we call this the second term. We plug a 2 in for n, we'd get 3. The third term, we're looking for the first 3. You guys have gotten the pattern by now. And really, speaking of patterns, sequences are patterns, okay? As you can see, this is going to list out all of our odd numbers. And if you ever want to create a sequence that deals with odd numbers in some way, shape, or form, 2n minus 1 is the explicit formula for the sequence of odd numbers. Right? The sequence of even numbers would just be 2n, because then we get 2, 4, 6, so on and so forth. And it does ask us for the 100th term, which is not a big deal, especially when we're listing, when we have the explicit formula. We would get 199 would be the 100th term of this sequence. We'll do maybe one or two. We'll do two more together. Let's skip B. You guys can do that for a little bit of practice if you read the agenda. What I want you guys to do for homework this evening, or for some extra work this evening, is to finish the problems that we haven't done in the video notes together. So this is sequence T, and it is n over n plus 3. If we want to find the first term, we're going to plug a 1 in for both of those, and our first term of the sequence will be 1/4. Our second term looks like it'll be 2/5. Our third term, if you guys are getting the pattern here, it should probably be 3/6. 3 over 3 plus 3 equals 3/6, which actually simplifies to 1/2. Now, this can be a little bit confusing. Okay, if at some point we will ask you, we will give you a sequence, then have you try to find the formula that would define that, the explicit formula. If we listed out 1/4, 2/5, 1/2 as the sequence, you might not think of this as 3 over 6, and it might be a little bit confusing to try to figure out what that sequence actually is. And then the 100th term, 100 over 100 plus 3, is exactly that. 100 over 103. Let's move on to D, because something interesting happens in sequence R here. We want to find the first term, so -1 to the first power over 2 to the first. Well, that's -1 over 2. Alright, the second term equals -1 to the second power over 2 to the second. We're just plugging 2 in where you see an n to find the second term. That's +1 over 4. The third term, -1 to the third power over 2 to the third power equals -1 over 8. And I won't ask you to do the 100th term, because 2 to the 100th power, that would get a little bit ridiculous. So, but it's interesting to see. Our first term was negative, our second term positive, and our third term negative. And if you think, maybe stop and think for a second, what's going to happen as this sequence gets bigger? The fourth term would be positive, the fifth term, and we call this an alternating sequence. When terms of a sequence alternate positives and negatives, we call it an alternating sequence. How might we have known that that was going to happen? This -1 to some n power, some variable, even if there was like an n minus 1 here, an n plus 1, an n plus 2, anytime we have a -1 to an n power somewhere in a sequence, it would make sense that it's going to alternate. Okay, because if we plug in even or odd numbers here, it changes whether this is going to be negative or positive, and it does nothing to the rest of the sequence. All this is basically multiplying by some version of 1, either positive or negative, and the n and which term it is just changes basically the plus or the minus sign, and we call that an alternating sequence. Alright, so you'll do B for a little bit of homework, and then you can check the key. Alright, speaking of finding the pattern here, we do want you to find the nth term. Basically, we're asking you to find the explicit formula for the sequence here. Okay? So we take a look at this first sequence, and with fractional sequences, when we have fractions, a lot of times you might not be able to find a connection or a link from one term to the next. Okay? How do we go from 1/2 to 3/4 to 5/6 to 7/8? Well, I could add, what could I add here? I could add 1/4 to 1/2, but adding 1/4 to 3/4, that's not going to happen, so it's not like we're adding the same thing. To get to 3/4 from 1/2, I would have to, if I was thinking multiplication, I'd have to multiply by 3 over 2, but multiplying this one by 3 over 2 is not going to give us 5/6. So in that case, if there's nothing added, nothing multiplied from one term to the next, sometimes it's easiest to think of the top and the bottom separately. Okay, so this is the first term, the second term, the third term, the fourth term. The top are all the odd numbers. We actually just talked about how to get the odd numbers. That was the 2n minus 1. Okay, and then just look back and check. All right, the first term, if I plugged a 1 in there, I'd get 1 on top. That's good. The second term, if I plugged a 2 in there, I'd get 3 on top. The third term, I'd get 5. The fourth term, I'd get 7. We feel really good about that. And then down on the bottom, this is actually all the even numbers. And we talked on the first page that just 2n would give you a sequence of even numbers. So we really thought about this as two separate sequences. And sometimes when you have fractional sequences, that's going to be important. And then I want you to try to figure out the explicit formula for this sequence, where this is the first term, the second term, the third, the fourth, and the fifth. It happens to be an alternating sequence, so something we talked about on that previous page might help as well. All right. Recursively defined sequences. All right. So up here we talked about an explicit formula where the sequence was written in terms of n, or in terms of the term number. We can also have sequences that are written dependent on the terms that have come before it. The Fibonacci sequence is one. The Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21, etc. Basically, you can find a term based on adding the 2 before it. 3 is 1 plus 2. 5 is 2 plus 3. 8 is 3 plus 5. 13 is 5 plus 8. And that's how we do that. Okay? And that's where these n minus 1, n minus 2 subscripts come into play. So this means the nth term. This means the term prior to the nth term. And this one means the term 2 before the nth term. And if we had an f of n minus 3 and a of n minus 3, it would be the one 3 before it. And obviously, we have to give you some information to deal with a recursive function. I have to give you maybe the first term, or maybe the first and second term, for you to use this sequence at all. All right, so let's check out example 3, and then we'll call it a day for part 1 here. Find the first 5 terms of the sequence defined recursively by this formula, this recursive formula, and we told you that the first term is 1. All right, well then the second term is going to be 3 times, this is the term before that one, so that's going to be where the 1 comes into play, plus 2. So this moved and became the term before it. This ends up equaling 3 times 3 is 9. The third term is going to be 3 times the 1 before it, plus 2. 3 times 11 is 33. The fourth term is going to be 3 times the term before it, plus 2. 3 times 35 is 105. And last but not least, the fifth term, 3 times, and this is getting a little tedious, the term before it. We have 3 times 107, which off the top of my head is 321. And that's how we deal with a recursive function. Sorry, you guys couldn't see that part there. Alright, so we're using the term before it. This here means the term before the nth term. The term before the one we are looking for. Cool? And we will get to, and that's, got one more example to do. Actually, I'd like you guys to try this example. Okay, what you're going to want to do before you find the 100th term, unless you want to count out this sequence to 100 terms, before you do C, do either A or B, and that will help you find the 100th term. I think one of these, either A, the explicit, or B, the recursive, is going to help you more for the 100th term. Okay, so we want A, we want the formula in terms of n, and B, we want the formula in terms of the term prior to it, a sub n minus 1.